Pressure. Here I've got a large weight, a huge hammer here, on top of a piece of wood, and in the piece of wood I have one nail, and underneath here that you can't see at the moment is a sheet of sticky tack. You can see that with this weight placed gently on, the nail has gone deeply in. There's a large hole there. We had a very small area of contact, just the end of that nail, and that has led to a large pressure, leaving a big hole. I then put lots of nails into the piece of wood, lay that on the same piece of sticky tack, put a large weight on top, gently, and this time you can see there's lots of holes, but they're much smaller. All of them are much smaller than this one. The weight here is supported by just one sharp point, whereas in this case the weight is supported by lots of sharp points. They're sharing out the weight, and so each one of them has caused a lower pressure and so less damage. Pressure is force divided by area, or P is F over A, and if the force is measured in newtons and the area in square meters, pressure is in newtons per square meter, but we give that a special name of the Pascal, or capital P lower A. It's a very small unit, and atmospheric pressure is around 100,000 pascals. So 5 newtons per square meter, for instance, would be 5 pascals. What I've done here, I've drawn round one of my shoes and I've calculated the area to be 237 square centimetres. I've found my weight here as 80.2 kilograms, well, strictly speaking my mass as 80.2 kilograms. Pressure is force over area. The force is my actual weight, which is my mass times the gravitational field strength. And so if I'm standing on just 1 foot, my mass of 80.2 kilograms times the gravitational field strength on Earth of 9.81 newtons per kilogram over the area of 237 square centimetres gives me 3.3 newtons per square centimetre, or 3.3 times 10 to the minus 4 pascals, as there are 10,000 square centimetres in a square metre. If I was standing on 2 feet, the pressure would halve. Applications of pressure. The humble drawing pin. With the drawing pin you have a large head on the side that you push. That means that there's a small pressure on your thumb so it doesn't hurt. There's a small point here giving a small area, and so a large pressure, meaning it will sink easily into a pin board. A mountain bike tyre or a tractor tyre. What we have here is the overall tyre is quite wide. That gives a large area so it wouldn't sink into soft ground so easily. But it has the little knobbles. They will sink in a little way till the tyre gets to its base. That gives a large enough pressure for it to sink in, and that gives it good grip in soft ground. A knife. With a knife you have a large handle. That gives a large area of contact with your hand, so a small pressure, so it's comfortable to hold. But a sharp edge, giving a small area and a large enough pressure to cut easily through the food. Here you see we have a digger, and it has very large caterpillar tracks here. That gives a large surface area to avoid it sinking into the soft ground.